what I want to cover here is I'm going to look at the 2002 Advanced Higher Paper question A8. Now in this question we cover the topic of partial fractions and curve sketching. So what I want to do, firstly it asks me to express x squared over x plus 1 squared in the form a plus bx plus 1 plus c over x plus 1 squared, stating the values of the constants a, b and c. It's then telling me there's a curve defined by this, and I want to find the equations for its asymptotes, stationary point in nature, and then sketch the curve itself. Quite a common question to see come up at advanced higher level. So first one, write it in terms of partial fractions. Top and the bottom have the same highest power, so we've got to do some algebraic long division. So in this case, we are dividing the top, which is x squared, by the bottom, so x plus 1 squared. Multiply out that bracket. What we'll get is dividing it by x squared plus 2x plus 1. And we should remember by now how to do algebraic long division. So x squared goes into x squared once. We then take the 1 and multiply all of this through by it. So we take away x squared plus 2x plus 1. So we take that away from this part here. What I end up getting is negative 2x minus 1. So I can start by knowing that the a is equal to this 1 here. So what that now gives me is I've then got 1 plus negative 2x minus 1 over x plus 1 squared. So what I now have to do is write this in terms of partial fractions. So looking at the denominator in the format of that one, what that tells me is I've got to write it as a over x plus 1 plus b over x plus 1 squared. And I know I'm going to set that equal to negative 2x minus 1 over the x plus 1 squared. So what I'm going to do now is I'm going to multiply everything through by x plus 1 squared to get rid of the denominators. And I'm going to end up with a bracket x plus 1 plus b equals negative 2x minus 1. So if I choose x equals negative 1, what I'm going to do is eliminate this term here, and I'm going to have b equals, well, if I substitute in x equals negative 1, I've got negative 2 times negative 1, which is 2. I'm then taking away 1. 2 take away 1 is 1. So I know b is equal to 1. Pick another value for x. Choose something that makes it nice and easy. So in this case, I'm going to go with x equal to 0. I then have a times 0 plus 1. So I get a. I've then got plus b, so plus 1 equals negative 2 times 0, so nothing, take away 1, that equals negative 1. So if I then have a plus 1 is negative 1, a has to equal negative 2 in this case. So I've now got the coefficients a, b and c for this. I can rewrite the entire thing out now. So I can then say is therefore x squared over the x plus 1 all squared equals the first a, so 1, it's then plus this part here over x plus 1, which would be the negative 2, so minus 2 over x plus 1. It's then plus the c over x plus 1 squared, so it would then be plus 1 over x plus 1 all squared. So that's me done that first part. So I've written it in the format at once. What I now have to do is answer the 3 questions that follow. So the first one of these was to look at the asymptotes of the equation. So rewrite the equation out. So I've got f of x equals 1 minus 2 over x plus 1 plus 1 over x plus 1 squared. Now there's 2 bits you can get for the asymptotes. We want the x asymptote and the y asymptote, so the horizontal and the vertical or non-vertical, dependent upon the equation of that asymptote. Now for the x asymptote, what we have to do is imagine that we can't have a situation where we divide by 0. So if we divide by 0, what we can't have is that x plus 1 equals 0. So for this, x equals minus 1, that there's our first asymptote. The second asymptote comes from this part here in front, because what we want to imagine is as we approach this asymptote, these values here get smaller and smaller and smaller, so this entire thing becomes negligible. So what that means is that our second asymptote is y equals 1. So I've got my two asymptotes now for the equation for when I want to sketch it. What I now have to do is gather up the other bits of information. So first things first, let's look at the stationary point. So we know for stationary points, we want to take the derivative of f of x. Now one thing I'm very quickly going to do is rewrite it. So I end up with 1 minus 2 bracket x plus 1 to the negative 1 plus 1 times, or just leave it without the 1 times, x plus 1 to the negative 2. What that means is when I take the derivative f dashed of x, what I end up getting is I get 2 bracket x plus 1 to the negative 2, take away 2 bracket x plus 1 to the negative 3. So if I then rearrange this, what I'll end up getting is 2 over x plus 1 squared, take away 2 over x plus 1 cubed. Combine both of these and put them over a common denominator, and what I'll end up getting is 2 bracket x plus 1 minus 2 over x plus 1 cubed, which then gives me 2x plus 2 minus 2, so that gives me 2x over the x plus 1 cubed. So there's my second derivative there, and we know for the stationary point, that has to equal 0. Well, for that to equal 0, the top line equals 0, so therefore the x value is going to be at 0 itself. 2x equals 0, x has to be equal to 0. To figure out the y component of the coordinate, what I'll do is I'll take the x equals 0 and substitute it in to the original f of x. So for that, I'll end up with 1 take away 2 over 0 plus 1, so 1 take away 2, plus 1 over 1 squared, so that's plus 1. So I'll get 1 minus 2 plus 1, so for that, I get that my y equals 0 as well. So therefore, my stationary point is the origin itself, 0, 0. What I now have to do is justify its nature. Now we know we can use a nature table in order to do this, but what I'm going to do at this stage is I'm going to do the second derivative, so f dashed of x. Now to do that, I'm going to use the quotient rule. So I'll end up getting 2 bracket x plus 1 cubed, take away 2x times 3 bracket x plus 1 squared. And that's going to be all over the bottom here, squared. So I've got x plus 1 to the power of 6 because it's cubed squared. So if I then take that top and just simplify it a little bit, what I'll end up getting is 2 bracket x plus 1 cubed minus 6x bracket x plus 1 squared, all over the x plus 1 to the power of 6. What I'm going to do is I could take out x plus 1 squared as a common factor here on top and then cancel it out for the bottom. What I'll then end up getting is 2 bracket x plus 1 minus 6x all over x plus 1 to the power of 4. Top, multiplying it out, I then get 2x plus 2 minus 6x, so I get minus 4x plus 2 all over x plus 1 to the power of 4. For the nature of it, what I have to do is substitute in the x value of 0, so what I have to do is figure out f double dashed of 0, and for that what I'll end up getting is 0 plus 2, so I'll get 2 over 1 to the power of 4, so I'll get 2 over 1, so I get 2. So we know that that there is bigger than 0, so I know is at that point it's going to be concave up. So I'm going to have a minimum turning point. So what I now need to do is bring all of this information together to sketch the curve at the end. So we have to remember when we're sketching graphs, a couple of key things we have to mark on. So we've got the information we've calculated, stationary point with its nature sketched, the asymptotes for both of them. What we also have to remember is looking at the axes, just making sure that they're drawn and labelled correctly. we have to look at x and y intercepts, and we also have to look at the behavior of the graph in the directions that are going to be relevant to us. So as it approaches the asymptotes, or as it tends off to infinity and negative infinity, nx. So start by just setting up our axes within our system, x going along there, and the y I've already drawn. So what we now need to do is mark on the information we've got. So let's start with the asymptotes. So I know I'm going to have one asymptote going up and down there at x equal to 1, sorry, x equal to negative 1. I'm going to have an asymptote going along there, this time at y equal to 1. So I know I've got that. I've got a turning point here at the origin, as we just calculated, and I know the general shape of it is it's going to be concave up. Now remember our function f of x, what we had was that was equal to 1 minus 2 over x plus 1 plus 1 over x plus 1 squared. So first thing we have to do is look at any intercepts that may occur. We already know it's going to touch the origin here, so we expect that one to come up, but let's imagine any others that are there. Remember, the original form is x squared over the x plus 1 squared. Sometimes that's easier to use. So if I've got that, for the y-intercept, x is equal to 0, so it cuts at 0. And for the x-intercept, y is equal to 0, so this has to equal 0, which means x squared is equal to 0. So I get the only intercept being the origin, i.e. where my turning point is. So I don't have to worry about doing any more calculations with that. What we now have to do is look at the behaviour as we approach the asymptote negative 1 from both sides, and as we head off to infinity and negative infinity in the x direction. So imagine what I'm going to do is I'm going to approach the asymptote at x equals negative 1, but I'm going to come from above. So I'm going to come this direction going that way. So what we have to do is ask ourselves what's happening to the equation as we do that. Well, if I get closer and closer and closer to negative 1, what's going to happen? The denominator of the fraction here is going to be positive in both cases. The size of x is going to be less than 1, and it's going to be that negative number plus 1, so that's always going to be a positive number. But as I approach 1, the denominator gets smaller and smaller, and if you get smaller and smaller denominator, the overall fraction increases in size. So it's going to increase in size, so eventually what's going to happen is these two fractions are going to absolutely dominate this one here. So the behaviour is determined by what happens with these. Now, as I come at negative 1 from above, again, negative number, but it's always going to be less in size than 1. So this is going to be a positive number, as is this because of the squared. But what's going to happen is that this fraction is going to get bigger at a quicker rate than this fraction because of the squared on the bottom. So this is going to be the most dominant term of the lot. It's going to increase in size in a positive direction. So as x tends towards negative 1, but from above, what's going to happen is that y is going to continue to get bigger and bigger and bigger and tend towards infinity. So it's going to go off in this direction here. Similarly, we have to think about what happens if we come at negative 1 from below. Again, the same sort of logic applies. Our fractions will be dominant because the denominators get smaller. This one here is going to be the dominant of the two. So as I come from negative 1 below, again, what I'm going to get is y tending towards infinity. So it's going to be here. Now we look at the behaviour as x tends towards infinity and negative infinity. So we're going off in the two directions, this way and this way, in my x-axis. Now if x tends towards infinity, what's going to happen is each of these fractions are going to get bigger on the denominator, so they're going to get smaller overall. So what's going to happen is that my y is going to tend towards 1. So f of x is going to tend towards 1 in both cases. But now we have to look at the direction it comes from. So as these get smaller, again, this term dominates this one. So it's going to be 1 plus something, so it's going to tend towards 1 from above. And that's also going to be the case as I go to negative infinity. So what's going to happen is it's going to tend towards 1 from each of these directions. So I've got all the key information. I now just need to fill the gaps. So I'm going to have a curve that looks like that. It's going to come down this direction here. Then I'm going to go off just above the y equals 1 and come back and head off there. So there you go. I've sketched the graph, I've marked down all the key information, and I've done the calculation.